To create the self-referential structure. Self-referential structure with alias name STU. Okay. I need a head pointer in main. This is the linked list head. Okay. H is equal to create list. Writing everything as a separate functions only. Okay. Create list STU star create list. Here again I need head pointer. Initialize to null. Don't forget this initialize to null. Okay. Then you need a temporary pointer. It's not required to initialize this, but still I am initializing just for safety. Then the last pointer null. These two are important. Making head pointer null, making last pointer null. Then take a choice. This program can be written in any way. I'm taking this user choice. Okay. Whatever is the creation logic, means you may go with a loop based, or during some other situation you want to decide linked list. Creation process will be same. But this last node, we are maintaining a last pointer here. It may not be always this way. You may have to find out the last node and then link. So here one extra step may be required. Here L is equal to M is not this simple. L is equal to find last node. Maybe. But this you have to do before. Here L is equal to find last node. You have to do this. If it is not done in a loop continuously, here I am creating the node, every node continuously without doing anything else. Okay. But suppose you are creating one node and then doing some other processing. Then you have to come back, find out the last node. If it is possible for you to maintain a pointer like this, you will. Otherwise, you have to always find out the last node and then link. Go next. Find out the last node and then this process you have to understand that you are finding the last node here. Instead of every time finding the last node, I am simply remembering last node like this because I am continuously creating the nodes. Create node I am writing as a separate function. As long as choice is yes, it will go on creating, otherwise it will stop. Okay, so this return the head pointer back to main after creation. I need to create a node. Here also I need a pointer, allocate memory. then this step is mandatory. N next is equal to null. Then return N. Okay. So here I am creating one particular node here. Here it is creating multiple nodes by calling this function and then finally returning only the first node address, that is head node address. Head node address it is returning. So this head node may contain just one node or 100 nodes, but I will only get the first address, first node address only I am getting from here to this main function. Okay, so here finally the entire list created will be in this H only. This is my linked list, only H is your linked list. Okay. Now this program execution is not useful because I can't see any output in that. I need to see the output also. So creation, after creation you need to see some output also by printing the list. So that list is created successfully or not, you need to check. For that we have another operation. Creation is over. Next is traversal. One of the operations in a linked list is traversing the linked list. Traversing the linked list, inserting or deleting. These are the common operations. Reversing, common operations that we need to learn in linked list. So traversal means traveling through the linked list, visiting every node so that we can go to the desired location. Okay, the desired location may be anything. Sometimes we may want to visit the entire linked list just to print, just to see what is the entire data we may want to visit. So traversal in a linked list is starting from the first node, visit every node in that linked list and find the last node. And that is the traversal process. It may not be always till the last node. You may want to stop in the middle. Maybe I want to delete this node. I may have to stop here only. But that is also traversal only. Okay. The traversal will always start with the head node. You have to always start anything from the starting node only. In linked list, you can't directly go to last node. You can't directly go to somewhere middle. Linked list, any operation you have to start from the head. Okay, because in linked list you will always assume that you have head pointer in your hand. That's it. Even if you remember the last node, you can't assume that last node will always be available. You have to write program using head node only. Right? So the head pointer you have in your hand, and last node even if you have, it is useless because in linked list we are doing single linked list here. Only one link is there for every node. Means I am going to remember your address. You will not remember my address. Means I can call you, you can't call me. That kind of list it is. Single linked list, only single directional. So this node has next node address. So if I go to this node, I can go to next node. If I go to this node, I can go to next node. Because every node is going to remember the next node address. But once you go to the last node, you can't come back because last node is not going to remember the previous node address. It is single directional travel only. You can only travel in this direction. You cannot come back. This is single linked list. Okay. Now traversal must always start with head. Once you go to the head node, get the next node address, go to the second node. Get the next node address from second node, go to the third node. This kind of traversal we are going to do next. Okay. So traversal for printing the linked list. Linked list entire printing we are going to do. Print list. So for any other operation, for creation is along with head we are going to create. But for any other operation, we need head node as the argument. For any other operation, we have to assume linked list is already created. Already created means what? What will be given to us? Head node address will be given. Okay. For any operation, you have to just assume head node pointer will be given. You will not get any other data other than the head node. There won't be size. How many elements are there? They will not tell you. You will only give head node address. You have to assume how many elements are there. No matter. You have to keep on doing the processing till you find the last node with next member null. That is your condition. Okay. So you have head pointer. You need, when you want to traverse, you have to have a pointer that will travel from one node to the next node. You have to store addresses, right? This node you want to visit means this node address you have to store. Again, you want to visit this node address means this node address you have to store. So that kind of pointer you need, temporary pointer you need, in which you can keep on changing the address so that you can visit that particular node. Okay, so here this head pointer is just a call by value argument. You can change it. You can take this as a temporary argument. Name can be anything. It need not be called head point only, but you are going to get the head node address. Okay, so with this head node address, you can visit the first node. You have visited the first node using T. T is your head node address now. Okay, T is the pointer where you have first node address. What is it? 1000. Using T, you can print ID number and name of the first node. After printing, you need to go to the next node. Okay, means next node address you have to fill in T now. So that T will point to the next node. Means 2000 should come here. Where is 2000? 2000 is here. When T was pointing to first node, how do you get this 2000 from T? T next. You get T next. T next is 2000. Now next step is T should point to 2000 means T next I have to copy into T. Okay, so for traversal, the most famous step you have to keep on writing is T is equal to T next. To move to the next node in linked list, the most common thing you will keep on writing is T is equal to T next, or P is equal to P next, N is equal to N next, whatever is the pointer name. You have to keep on moving to the next node. Then simply next pointer address you will copy into the same. This is like increment. In our array, if you have to keep on going, index you will increment, right? This is your index. T is your index, you can assume. But it is not increment, it is next. Next, you will move. Okay? So you will write a loop where you are going to move next. T is equal to T next. For everything you have to keep on doing this one. T is equal to T next. Then before moving to the next, you will print the values. Print ID number and name. How to get ID number? T arrow ID is your ID number. T arrow name is the name. When T is here, when T is pointing to the first node, I am going to use T to print ID number and name of the first node. That is here. Then I have to move to the next node. Moving to the next node is copy this address here. This is T next. T next I am copying to T. That is what here. T is equal to T next. So that 2000 is copied here. So that T is moving to the next node. Okay. Again in next iteration, print the ID number of next node. 2 and D will be printed. Then T is equal to T next. What is T next now? T next is 3000. 3000 is copied to T. That means T is now going to third node. Right? Again, go back. Print the value of ID number and name of the third node. Then T next you will copy to T. What is T next? 4000. 4000 you will copy to T. So that T is now pointing to the next node. Again print ID and name. Again T next. What is T next? Null. Null you will copy to T. Means T will become null now. Now T is not pointing to any node. It is pointing to null. Okay, once you get null into T, you cannot move any further. Means you have to stop. So now your condition is when T is null, you have to stop. Means as long as T is not null, go on. That is your condition. Right? Traversal will take the head pointer as the argument. It does not have to return anything, so it's a void return type function. While T is not null, print the ID number and the name of every node. T arrow ID, T arrow name. Then T is equal to T next. We'll do A is equal to A plus something, no? It is similar to that only. So this function I am going to call after the create list. Traversal of H or print list of H, whatever is the name. I have taken traversal as the name. So I am simply calling that function by sending this head pointer as the argument. Okay. Now let's execute and see if the list is created properly or not. Enter ID, name, another yes, ID and name, create another S, ID and name, create another S, ID and name. No. This is the list. ID number name, ID number name. The list is created properly. Okay. Understood everyone? Same program you have to repeat. That is your assignment. Okay. Without looking at your notebook, you have to do it. Do it. Do it 3-4 times if you want to. But this is very important, creation. And the creation will not be given in a simpler way like this. They will give different conditions, like I will give different numbers, keep them in sorted order, or a string will be given, create a list of characters with the string. That kind of assignments will be given. Okay, so first do this perfectly and understand what is happening in every step. If you understand, you can change it and write your own linked list programs later. Okay, any questions? Or are we done for today? Okay, see you tomorrow. Thank you.